Okay, so how does Earth's albedo contribute to global warming? Explain exactly how the albedo is causing this global warming. So it's very important that we kind of break down this question into the different things that we need to talk about. So one is, what is albedo? So first off, we need to know what it is. Number two, what's an example of an albedo loop on Earth? Okay, so what is one that will cause warming? And how does that loop cause the global warming? Okay, so first off, albedo is the measurement of the amount of reflection. So the darker something is, the least it's going to reflect. It absorbs more energy. So like if we have something that's pure black, it's going to be an albedo of 0 because it's not going to reflect. Whereas something that is white is going to reflect a lot of light, so it gets closer to the 1. So the higher the albedo, so the more it reflects. Okay, the lower the albedo, the less it reflects. Okay, so here's an example. If we're talking about the Earth, we have up in the Arctic oceans, or Antarctic oceans, we'll have water, and then we'll have ice, glaciers, Greenland, anything that's ice, snow, anything like that. Well, if we look at the albedo of different objects, so ice is white, so therefore it's going to have a higher albedo. It reflects a lot more light. So if we look at this, we can see that off of snow and ice, we can get 90% of the sunlight reflected. 90%, that's pretty huge, where only 10% of the light is actually absorbed in the ice. So it's not going to melt very much because it's sending most of the solar rays away. But if we look at water, okay, water is darker because, well, it's darker. Yes, water does reflect some. So water will reflect about 6% of the sunlight. So that's not very much. So 94% of the sunlight's absorbed, which means the water is going to take on more heat from the sun because it doesn't reflect as much, where the ice is going to take on a lot less. So the ice will stay colder where the water will start warming. Now, here is where we look at the cycle of this. We can look at this and we can look at the ice retreat. So number 1, we can see as the Arctic ice warms, ice cover melts, exposing more of the less reflective water. So ice gets warmed up, it starts melting, and more blue water is showing, which absorbs more heat. So now we have the exposed water absorbs more sunlight, so it's warming up, and the air grows a little bit warmer around it. So what happens? The ice melts. Okay, so ice is melting, more water's showing, more heat, more ice melts, more water showing, more heat, more ice melts, until finally you got no ice left. So here's another picture here. So we have, since it's such a big feedback loop, so we have sea ice melting. Oops. So we have sea ice melting, which decreases the albedo because now we've got blue, or not white, showing, so it's absorbing more solar radiation. Since the ocean is absorbed more, it's warming up. So now it has absorbed more heat. The temperature rises, more sea ice melts, the surface decreases, the ocean absorbs more heat, more temperature rises, until finally there is no ice left. So I hope this was a little bit helpful of being able to describe why albedo can contribute to global warming.